The more complicated the statement gets, the more complicated the truth table gets. And in particular, the more columns the truth table ends up having. In this example, I've just given you an already symbolized statement because what we want to do is work on just our truth table skills for a moment. So this statement is already symbolized. You aren't told what P and Q actually represent, just the relationship between them. We only have the form to work with here. What I haven't given you is the columns already set up. We're going to set up the columns ourselves. And one of the skills that we're going to build up is figuring out what columns we need and how many columns we need. So let's start with the rows. We'll start with the rows and with columns for our simple statements. We have two simple statements, so we need 2 to the second power equals 4 rows. We'll have a column for P and a column for Q. Do not worry, by the way, about how beautifully you can draw long straight lines here. It's okay if the straight lines are a little bit messy. I do recommend doing this on lined paper because it's important to keep track of what's in what row, and the lined paper helps us keep track of rows. So filling in our Q column, we just alternate true, false, true, false. And then in our P column, we'll have 2 trues, 2 falses. Okay, now what columns do we need? First, we need a column for negations of simple statements. Looking through here, I see a not P, here's a Q, here's a not that's outside some parentheses, here's a Q. I don't see any not Qs. So this statement uses a not P but not a not Q, so we'll have a not P column. Not P has the opposite truth value from P. So when P is true, not P is false. P is true, not P is false. P is false, not P is true. P is false, not P is true. Okay, so that's the first step, negations of simple statements. Next, we look for the inmost sets of parentheses. So what do I mean by the inmost sets? Well, if we have 2 sets of parentheses, one inside and the other, the ones that are inside are the inmost sets. In this example, we have this set of parentheses and this set of parentheses. They are not one inside the other. They're at kind of the same level. So we will make columns for both of those right now. One of those was not P, then Q. And the other one was P, if and only if Q. So not P, then Q. And I'm being careful with my column width here because even though I didn't tell you how many columns you're going to need, I figured out exactly how many boxes here we were going to need so that I wouldn't end up running out of space on the page. So as you're writing this, you probably want to match my column widths. Okay, and then we go through and compute these one by one. Not P, then Q. Well, the only way for the conditional to be false is if the if part is true and the then part is false. So going down the rows, here the if part is false, the conditional is true. The if part is false, the conditional is true. The if part is true, we have to look at the then part. The then part is also true. So the conditional is true. Here the if part is true, the then part is false. That's when the conditional is false. So we end up with 3 trues and a false in that column. What about P if and only if Q? That's true whenever they have the same truth value. So P is true, Q is true, if and only if is true. P is true, Q is false. Those are different. If and only if is false. P is false, Q is true. Those are different. If and only if is false. P is false, Q is false. Those are the same. If and only if is true. Whenever I finish one of these steps, I like to stop and take a deep breath, just because it's really easy to get caught up in working on this stuff and forget little things like breathing. What have we got next? Next, we're going to look for negations of statements that we've already symbolized. So we've already symbolized not P. We don't have a not P. We've already symbolized not P then Q. We don't have a not attached to that. We've already symbolized P if and only if Q. That has a not attached to it. So that's going to be our next column, not P if and only if Q. So how do we compute this column? Well, we're doing not to P if and only if Q. So we're going to have the opposite of whatever truth value P if and only if Q had. Here the statement is true, its negation is false. The statement is false, its negation is true. The statement is false, its negation is true. The statement is true, its negation is false. Okay, that wasn't too bad. What's left? Well, if we have parentheses inside parentheses, after we've finished all the negations, we go out a layer. In this case, we've symbolized all of the pieces now. All that's left is the whole statement. So we'll have the whole statement. And this is very long. It's easier to write if you don't try to say it while you write it. Now, in today's installment of Mathematicians Are Lazy, in many cases, instead of copying out that whole statement, I might just write the words, the whole statement, in this space. Just because I think I'm more likely to make a mistake in copying out that whole statement than in any work I might be doing. What is this whole statement? It is this column, not P then Q, or this column. I'm going to do OR to the truth values in those two columns. OR is true if at least one of them is true. It's false if they're both false. So, this column is true, this column is false. OR them together and we get true. This column is true, this column is true. OR them together and we get true. This column is true, this column is true. OR them together and we get true. This column is false and this column is also false. That's the only condition where OR is false. So here, the OR is false. And again, this column, true, 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 false, that's our final answer. Finding out the contents of that column was our goal in this exercise. Everything else we did here was working toward finding out that column.